Hello all, welcome back to Success EduTech. Today we are going to continue with the series of Science and Technology, chapter number 4, which is Measurements of Matter. In the last 3 chapters, which we have already covered, we studied about the physical science, which is physics. Now, from this chapter, we will study about the chemical science. So here we start with the measurements of matter. Everything in this universe is a matter. Okay, so considering all the things in the universe to be a matter, we start up with the concept of laws of chemical combination. Then we will study about atoms, its shape, mass and valency, the molecular mass and the concept of mole, the radicals. Now, what is the Dalton's atomic theory? Do you remember? How are the compounds formed? What are the molecular formula of a salt, slate lime, water, lime or a limestone? In the previous standard, we have learned that compounds are formed by chemical combination of elements. We have also learned that an important principle of Dalton's atomic theory is that molecules of a compound are formed by joining atoms of different elements. So, with the help of this theory, I will explain you about laws of chemical combination. The composition of a substance changes during a chemical change, they say. That means whenever we perform an experiment or a chemical reaction, the composition of the substance will change. The scientists Dalton, Thomas and Rutherford studied the structure of substance and atoms and thus discovered the laws of chemical combination. Whenever there is a chemical combination happening, that is a chemical reaction, the composition of the substance will definitely change, they say. The fundamental experiments in this regards were performed by the scientists in 18th and 19th century. Scientists could then write the molecular formula of various compounds on the basis of Dalton's atomic theory and the laws of combination. That gave them the output as some new compound. Here in the figure 4.1, you can see that there is a verification of law of chemical combination. See, inside the flask, they have taken a solution of calcium chloride, which is CaCl2. Also, inside the flask, there is a small test tube in which solution of sodium sulfate is taken, which is Na2SO4. At first, it is not mixed, but for the second time, here on the second weighing machine, we have mixed it. When it has been mixed, the two chemicals are combined and some new compound is formed. The white precipitate after the reaction is of CaSO4, which is calcium sulfate. From sodium sulfate, it became a calcium sulfate in the solution of NaCl. The calcium chloride now has become sodium chloride. So NaCl is the formula for salt. So this is the verification of law of chemical combinations, which shows you that the composition of the substance, it changed. Previously it was CaCl2, now it is NaCl, whereas Na2SO4, which was sodium sulfate, has now become a calcium sulfate. Then we shall learn about the second law, which is law of conservation of matter. In the above activity, the mass of the above activity was this: the mass of the original matter and the mass of the newly formed as a result of the chemical change are equal. In 1785, the French scientist Antoine Lavoisier inferred from his research that there is no rise or drop in the weight of the matter during a chemical reaction. So whenever there is a chemical reaction, the weight doesn't change, the mass doesn't change. I will prove you from this experiment itself. In a chemical reaction, the total weight of the reactant will be same as the total weight of the product formed due to the chemical reaction. So when the chemical reaction takes place, At that time the matter is conserved, whereas the composition changes. Like you can see here, the flask is placed on a weighing machine. Here the weight is 300.23 gram first. Then when we have mixed or we have chemically reacted the two compounds, the weight is 300.23 grams. So the weight remains the same after the chemical reaction also. There is no rise or drop in the weight of the matter during a chemical reaction. This proves us the law of conservation of matter. Do you remember we studied the law of conservation of energy? Similarly, matter can neither be created nor be destroyed. Whatever is there in the universe, the total amount of matter in the universe remains constant. It just can be changed from one form to another form. The example which you can see here. Now moving on towards the law of constant proportion. These laws are very important to understand about matter. In 1794, the French scientist J.L. Proust stated the law of constant proportion as the proportion by weight of the constituent element in the various samples of a compound is fixed. The first we saw was the composition in the chemical reaction changes. Second, we saw that the weight of the matter will remain same. Third is the law of constant proportion, where the proportion by weight of the constituent element in the various sample, that means the proportion remains it is fixed. For example, the proportion by weight of hydrogen and oxygen in water is 1:8. That is for H2O, it is 1:8 proportion. So this means that total 9 gram of water is formed by chemical combination of 1 gram hydrogen and 8 gram of oxygen. So 1:8 proportion is taken for H2O. Similarly, the proportion by weight of carbon and oxygen in carbon dioxide, here in carbon dioxide it is 3:8. What does 3:8 means? For example, in a 44 gram of carbon dioxide, total there is 44 gram of carbon dioxide, there is 12 gram of carbon and 32 gram oxygen. So 12 plus 32, it comes out to be 44. So 12 grams out of 44 is for carbon, whereas 32 gram out of 44 is for oxygen. Together the proportion by weight of the carbon and oxygen is 3:8. So here it is 3:8. Here it is 1:8. So from the entire water, if you pick out one molecule of H2, which is not possible to take out one molecule, but I am telling, if you take one molecule of H2O, you will find that the proportion is 1:8. 1 for hydrogen and 8 for oxygen. Okay, so proportion by weight of the constituent elements in the various samples of a compound is fixed. Then only it will be termed as H2O. Then only it will be termed as CO2, nitrogen dioxide or nitrogen oxide. For all of them there is fixed proportion by weight. So in short, we have studied the law of chemical combination, law of conservation of matter and law of constant proportion. Here the composition of the matter changes after the chemical reaction, whereas the weight or the mass, it remains the same. Here the proportion by weight, it remains same. So we have covered these 3 laws. In the next coming video, we will be completing with the new concept, which is atom. We are going to study its property, and further we can check out many of the concepts which will make us clear about what is a molecule, element, compound, what is molecular mass, and so on. The Avogadro's number you will study. There are many things to study about a molecule in this chapter. With this, I would like to conclude today's lecture. Thank you for watching. Don't forget to like, share and subscribe.